Hi everyone, welcome to my channel. My name is Fikrat. Today we're going to talk about one of the hidden gems in Databricks called System Tables. System Tables is a feature that collects information about pretty much everything that's happening within Databricks. This is a relatively new feature. I have recently discovered it and I was amazed on how easy it is to use and how much information you can collect using system tables. Join me to learn more, and I am sure you will love system tables as well. Alright, so here are the topics that I'm going to cover today. So we'll start with the overview of system tables, where I'll explain the purpose, some of the common use cases, as well as explain some of the technical details about scope, latency, data retention, and so on and so forth. Next, we're going to have high-level system tables walkthrough, where I'll explain the purpose of each system table. Next, I'm going to show how you can enable system tables. So at the time of recording of this video, some of the system videos are still in preview, but you can easily enable them using Databricks APIs. Next, we're gonna deep dive into system tables, where I'll show content of different tables and share my thoughts about how the data from these tables can potentially be used. Finally, we're gonna build dashboards for cost and performance analysis using system tables. A quick reminder, if you are new to the channel, please subscribe and show the support to the channel by liking the video. A big thanks from my side for that. Let's get started. So let me start walkthrough of system tables with this Databricks documentation, which I'm gonna share in the description of this video. So it has all the detailed information about each type of system tables. So if I scroll down, you will see a table which contains information about system tables type. So its nature. We have system tables fully qualified name. So by the way, all of the system tables are located on the system Unity catalog, but you will see that they are grouped under different schemas. So in this case, we have access schema, which contains multiple tables. Another useful column here is free retention period, which will tell you how long this information will stay in system tables. So as you can see, for some tables it's 365 days, whereas for some tables it's more. It's in this case unlimited, and we have tables where retention is only 30 days. Another useful information in this table is whether or not any particular system tables support streaming. So why it's useful? As I mentioned, system tables contain information about one particular region, and if you have multiple regions, you can build streaming pipelines which will collect information from different regions and basically have centralized reporting where all this information will flow to. So let me describe some of the useful system tables. I'm not gonna cover everything, so I'll let you study this page. Audit logs allows you to track information about security information mostly, but you can also see events like queries, clusters, and so on and so forth. Table lineage and the column lineage, they contain lineage related information, which will allow you to see lineage on different granularity. So this is the same information that you can see from Unity catalog page graphically as well, but here you can get it in nice data format, which will allow you to build different kind of reporting. Billable usage and the pricing, they are cost related tables. So usage contains information about start and end time of your resources, whereas pricing reflects pricing for different types of resources. Then we have several cluster related tables, all of them located on the compute schema. So clusters tables containing general cluster related configuration. Node timeline contains cluster nodes information, so when each node started, ended, and so on and so forth. So that's very useful to understand performance of your clusters. And you can also get some lookup information from node types. Then there are several warehouse related tables. So SQL warehouses contains general information about your warehouse, configuration, history, and so on and so forth. We have warehouse events, which includes information about when your warehouse started and ended, which also could be useful for cost analysis. A few jobs related tables located under Lakeflow schema. Again, some of them includes generic job related information, whereas some of them have more granular task level information, including the start time, end time of each task, as well as job related timeline information that you can see here. There are some marketplace related tables as well, which could be useful if you are using marketplace. Then we have predictive optimization table, which allows you to get information about events that's happening as part of predictive optimization. For those who are not familiar with predictive optimization, this is another preview feature which allows you to automatically tune your systems. So it's a great optimization feature. Some other event types like Databricks Assistance events, if you are using Databricks Assistance, this is another smart tool within Databricks. You can get information about questions asked with Databricks Assistant, answers, and so on and so forth. And then there are some query-related information, which allows you to track queries coming from serverless compute. If you are using notebooks connected to serverless, then you will see commands executed within these notebooks. So this table will also contain queries that users run within the SQL warehouses. And then there are some machine learning model related events. So as you may know, Unity Catalog allows you to host machine learning models, and these tables will track information about machine learning models, machine learning serving endpoints, and so on and so forth. The last event type in the table is network access, which could be useful for security purposes. All right, enough of theoretical talk. So let me demonstrate some of the system tables in Databricks, as well as I will show you how you can enable some of the system tables. So I'm in my Databricks workspace. So if I navigate to Catalog tab, I'll see all of my Unity catalogs. And here we have System Catalog, which I have expanded. And underneath, you can see multiple schemas. So in your system, you may see less system schemas, and that's because some of them are currently under preview. All right, now let me explain how you can enable some of the system tables. To do that, you'll need to collect few pieces of information. So first of all, you'll need to have method store ID for your Unity catalogs, and you can get it easily by navigating to one of the Unity catalogs and opening the details. So method store ID will be at the top. Next, you will need to have your Databricks URL, which you can collect from your browser's address bar. And finally, you will need to have personal access token. So it's PAT in short. So let me quickly show how you can generate one. So you can go to your user properties, open the settings, developer, access tokens, and from here you can click this generate new token button, and that will open you dialogs box where you can specify how long that token will be active for, as well as you can copy your access token from there. So keep in mind that once you have closed that window, you won't be able to access it again. So make sure that you store it somewhere. In my case, I have stored all this sensitive information in my Azure Key Vault, which is a secure location, and I'll show you shortly how you can access it within your notebook. So with this preparation, let me go back to the notebook. So this is a notebook that I'm gonna share in the description of this video. It contains all of the exercises that I'm gonna share today. The first cell in this notebook contains Databricks URL, so make sure that you replace it with your Databricks URL. And then we have MetaStore ID and the path token. Again, you can either place them in Key Vault, or if your purpose is just to run it once and see how it works, you can just put it in the notebook, run it, and then discard them. So make sure that you remove them, because this is a sensitive information and it's not good to keep it in open format. Okay, so let's see how we can enable system tables. So my next command here, as a command 3, uses all the information that I have described earlier, and issues request command to refer to Databricks API. So you can see Databricks API here that we're calling for. It's a get method, and it will bring you a list of all of the system tables. So let's take a close look at the output of this command. So what we have here is a schema information. So you won't see table level granular information here, but so basically all these tables will be enabled on schema level. So what we have here, schema's name, so in this case access schema, and then state. So enable completed means that this system schema is already enabled and ready to use. When you run this command, you will see lots of system schemas set to available state. So available means that the schema is not visible yet, but you can enable it using Databricks APIs, which I'm going to demonstrate shortly. Then you will find some of the schemas marked as unavailable. At the moment, they are not available for enabling, and I am assuming that Databricks will make them available sometimes in nearest future. All right, once you know which schemas you want to enable, then you can use command 5 to enable this schema. So I have several commands here, so 5, 6, and so on and so forth, each one for particular schema. So this one is to enable access schema. As you can see, they are pretty much similar, except we have schemas that we are enabling as part of this API call. If these schemas are not enabled for you, you can run this one by one. If the command runs successfully, then you will see response like this, 200, which means that schema was successfully enabled, and then hopefully you will see something like this. And as I mentioned earlier, under each system schema, you will find several system tables. So you can see 5 or 6 different tables under access schema, and so on and so forth. All right, now let's have a deep dive into different types of system tables and see what kind of information you can extract from them. So let me start by audit table, which is one of the important tables collecting audit from different systems and events. So here we can see account ID, workspace ID information. So as we will see shortly, you will find information from multiple workspaces if your account contains multiple workspaces. You have information about timing of the event, a user that performed certain actions. Action name, service name is useful information that will point you to the category and the event type. And then you have all the different metadata information related to user identity, identity metadata, which will contain detailed information about service principals that executed certain commands. In command 10, I have extracted distinct list of service name and action name just to give you idea about what kind of information you can get from this table. So if I scroll down, you can see that there are a lot of event types related to security. So we have accounts category, and under that we have different events like delete, add, token generation, and so on and so forth. We have information about clusters. As you will see shortly, there are cluster related system tables as well, but you get different types of information from these dedicated tables versus audit tables. So audit tables will contain mostly audit information, as the name implies, and that will allow you to see who did what and when. Some of the useful information about dashboards, which will allow you to track different user actions. So who started a certain dashboard, who created what, who deleted dashboard, and so on and so forth. And lots of information on the Databricks SQL category, which will allow you to see different queries fired within your warehouse, alerts, and so on and so forth. So here is another example in command 11 from audit tables, where I am extracting commands that has been executed within my system. So some of them will be within the notebooks. So I mentioned earlier that there is special system tables which contains information about queries that were run on serverless. However, this information from audit table that are related to run command action, they represent queries run on different kind of compute. For example, if your users are running commands within the notebooks connected to clusters, then you can find these commands here in this table. Okay, so let's take a look at lineage information. So in command 12, I am extracting information from column lineage table. And if I scroll right, here you can see workspace ID, source related information. So sometimes this source of your data may come from table, whereas sometimes it will come from files. And accordingly, you will have either table level information. So it's catalog name, schema, and table name. But if the data comes from flat files, you will see only path related information. If I scroll right, you will find destination information or target information, and the target type will show you what kind of target we are writing into. And finally, we have column level information where we have target column name. I think I missed source column name, which is right here. Again, this information could be very useful if you are documenting your system. So basically, you have already your table source and the tables. You have ETL process in your system, and you just want to show relationship between the source and the destination on a column level. Command 13 has similar lineage information, but this is on table level. Command 14 has list prices example. So here you will find prices for different Databricks resources. It's historical data. It will show you when that particular price was relevant for that particular resource. So most important column here is a pricing column. So you can expand its complex column where you have a default column, and I'll show you shortly how you can use it to calculate US dollar amount for your resource consumption. Billing usage is another cost-related table where you can actually track all of the resource usage here. So if I scroll up, you can see SKU name, which you can use to join to price table that we just discussed. And then you can get detailed information about start and end time of your resource usage. You can get some custom tags. Also, sometimes tags could be useful to group your resources together. Usage unit and then exact usage amount. So this is in usage unit, so it's not dollar amount, but there is a formula that will allow you to convert to dollar amount. So that I'm gonna demonstrate shortly. And then there are some useful information on the usage metadata. So you can see a cluster ID associated with this particular resource, which you can use to join against cluster information. That's something that I'm going to demonstrate when we build dashboards. So we basically will take all of these specific system tables and we'll join them together to get some meaningful dashboards. And we have some identity information here as well. Okay, so moving forward, we have several commands starting with 16 that describe clusters. So as you can see, we have lookup information about clusters. For some of the clusters, you may find multiple rows because it will contain historical information about change to the cluster. So, so in this case, my cluster has changed at a certain point, and it will show information about the previous and the current state. So node timeline is another computer-related system table, and it's very useful for cost analysis. So if I scroll to the right, you can see start time, end time, and then you can basically correlate this information against resource usage, which I'm going to show a little later, to understand which nodes are responsible for the most of the cost. You can also find here very useful node-related performance metrics like CPU user percentage, so memory use percent, for example, here. This could be useful for analyzing how efficiently you are using your cluster. So in other words, by analyzing historical usage trends, you can conclude on whether or not you are using your clusters efficiently. Okay, so beginning of command 18, I have two commands here. The tables, information schema.tables, and columns system tables. So they contain metadata information about all of the tables within your Unity catalog. So you can get catalog schema and the table name here, and this you can use to build data modeling. So in one of the past projects, I have extracted all of this information, so table information and so column information. I basically correlated them, so joined them, and extracted this information to model diagramming application, and that allowed me to see nice data modeling with all the relationship between different tables. So that was very useful. Okay, continuing this description, in command 20 we have a lake flow schema which contains several system tables. So this one is for jobs, which allows you to see job name and some of the generic job related information like who created it, when it was created, and so on and so forth. Finally, I have few commands which tracks information about queries. Query history table contains information about commands that you have run from serverless. Alright, now that we know what kind of information to extract from system tables, let's use this knowledge to build some useful dashboards. Before we do that, let me show you relationship diagram between system tables, so you can find it in the same Databricks documentation I shared earlier. So let me navigate there. Here at the bottom of this document, you will find this nice diagram which shows ERD relationship between these tables. So for example, if you take billing usage table, you can see that it's related to list prices on SKU name field. You can also see that there are certain fields on the usage metadata. So usage metadata, in this case, a complex field. So some subfields on the usage metadata point to other tables. So in this case, let's say we have job ID, which is pointing to jobs table. So I use this relationship to build some queries, which you will find at the bottom of this demo notebook. So that's beginning command 25 and below. And I'm going to describe these queries in a moment. So now let's go ahead and create our dashboard. For those who have not used Databricks Dashboard, it's a great and easy reporting tool which is already built in within Databricks, and you can easily build your dashboards by navigating to Dashboards tab. So let me go here, and here I already have few dashboards, but you can use create dashboard button, and from here you have to follow few steps. So first of all, you have to put query inside data tab here, so you can use either select a table if you are pulling the data from single table, or you can use create from SQL button and put your query here. So for example, I'm gonna copy paste this query from here, in data panel, run the query. So this is mandatory step. And once your data is displayed here at results tab, you can switch to design canvas and start adding charts to your dashboard. Once you select the chart, you have two options here. You can either type what kind of chart you want to build in simple English, and that's a nice AI feature that will create a chart for you. Otherwise, you can also configure this chart properties here in widget panel. So you can select your chart type, and you can select x-axis from available columns, y-axis, color, and so on and so forth. Keep in mind that you can have more than one data set. So if I navigate here, make sure that you put meaningful names to these queries so that it will be easy to select from canvas. And once you have list, you can navigate here and select necessary data set from here. Once you put necessary charts, you can name your dashboards right here at the top. And finally, you can have more than one page. So we have the first page. Let's name it to compute costs. And then you can use this little plus button to create another page, which you can dedicate to queries, for example, and put another set of charts here. And you can navigate between these tabs like this. Okay, now that we know the basics of Databricks dashboard creation, let me open the dashboards that I already created and explain its design. So I have created cost analysis dashboard, which has multiple tabs. to analyze costs from different angles. So I have created 4 pages here. So one for generic compute related costs, another for cluster related costs, and then I have warehouses costs tab, and finally I have jobs related tab. Let me start with general compute tab. Here I have put together a few charts which shows cost analysis by resource SKU names. So this is a pie chart. I have few more charts here in this page, but let me first explain the queries behind this chart. So if I scroll to the right, you can see that this chart is tied to all compute query. So let's switch to data tab, and this is my all compute query. So for this query, I am joining billing usage table with list prices table on SKU name column, and use additional usage start time, end time columns from both sides so that usage timing would match timing of the SKU price. Remember, the list prices that I have described earlier has history of prices for different SKUs, which may change over time. So this extra condition will ensure that we are matching usage to right list prices. Once these two tables are joined, I take usage quantity from usage table and multiply it to this SKU's price. And to do that, I am extracting default and effective list elements under the pricing column from list prices table. So that will give me price in dollars. And then I have some other complementary columns that I'm going to use within my charts. Let me switch back to the canvas. So my first chart is again pie chart, and I'm using sum of usage cost as an angle. I use SKU name as a color, and that will give me usage costs by SKU. Here's another chart. So in this case, it's a bar chart, but it's using the same data set. And this chart displays costs by SKU and the weekly period. So if I scroll to the right, you can see that I'm using usage costs as y-axis, and I'm using billing origin product column as legend. Actually, I should have renamed the title of this chart. So this is by product rather than SKU. And at the bottom of this page, I have another chart which analyzes costs by SKU, and I am using different types of chart here. So one thing to notice here is that you can actually select one of the segments of this chart, and other charts will reflect the filtering choice selected to that chart. So for example, so this is my cost by SKU, and if I select this particular SKU, you can see that other charts have changed to reflect data related to that particular SKU. So to summarize, this page would allow you to see costs by different products and SKUs. But if you'd like to go a little further and understand nature of your costs, we'll need to go to other tabs which are dedicated to this compute type. So let me switch to clusters tab here, and let me select one of the charts. Here I'm using different data sets called clusters. So if I switch to the data panel, now let's navigate to clusters query, and as you can see, this query is a little more complex, where I'm using common table expressions with with clause, and you can see that I have several subqueries here. The first subquery is similar to what we have seen. This will bring the general cost related information, and then I have cluster subquery, which brings the list of clusters so that I could extract its name. So notice that I am using raw number function here, and that's because I may have more than one version of each cluster record. So remember that this clusters table is historical table. You will find multiple versions, and you would normally want to take the latest version of the cluster. So as you can see in my final select statement, I am filtering down to one version of the cluster in order to deduplicate. So another subquery is commands. So here I'm extracting data from audit table. Finally, I join these subqueries together to get my final dataset query. Now let me switch back to the canvas and take a look at the charts that I have created here. So here I have a chart which will show my cluster cost by owners. Another chart will show the cost by cluster names. And if I scroll down, at the bottom I have a scatter chart to show query execution time. So right now it doesn't show the data because with the filters that I have added to the page, there is no data to be shown here. I have added a couple of filters on this page. So this filter is a range slider filter, and I have selected usage cost, so I can change the slider here and see different range. So for example, if I am not interested to see smallest cost clusters, then I can use this slider to focus on higher cost clusters like this. Now if I bring this slider to the minimum, I'll get more data, and I'm gonna change this slider as well. This filter is associated with query execution time field, and if I now change the sliders a little bit, hopefully I can get data on query related chart. There you go. Here I have query execution time by days. So let me select this chart. So you can see that my x-axis is based on event date. My y-axis represents execution time. Another thing to notice here is that I have assigned tooltip field for this query. So in this case, this tooltip is going to be the text of the command. So if I hover on some of the slowest queries like this, I can see the command that's behind this. So to sum up, this page shows cluster related cost analysis alongside with query execution time chart, which would allow me to do a little bit more detailed analysis to understand which queries are behind my highest cost. Okay, moving on. So let's navigate to the warehouses tab. Here I have similar charts. So let me first show you the query behind this. So this is warehouse dataset. If I switch to data tab and select warehouses, I can see similar type of common table expression query. And the first subquery is the same here, but then I am using warehouse specific subqueries here. So you can see that I am selecting from warehouses system table. As for queries, I am bringing this data from query history table. So if you remember, this table represents query performance data for queries run on the serverless context. So that could be a serverless from serverless associated with your notebooks or SQL warehouses. And like the previous query, I have joined these few subqueries at the end to get data related to warehouse. So let me switch back to the canvas and take a look at the chart. So this chart is very similar to the previous one, the cluster one, except this one is related to warehouse. So I can analyze my cost by warehouses. Here I have heat map type of chart where I have a warehouse size on x-axis and the warehouse type on y-axis. And if I scroll down, I have chart which show performance of individual queries. So this is again based on execution timelines, and I have total duration for each query. And like with the previous tab, I can hover on individual queries and I can see the queries associated with this particular execution. So here it's very easy to find out outliers from execution performance perspective and then focus on their performance. Finally, let's take a look at the jobs tab, which contains two charts related to jobs. So with Databricks, you can have workflows for orchestration purposes, but you can also have Delta Live table pipelines. And the data for each of them will come from different tables. For this chart, I am using jobs dataset. Let's take a look at jobs query. I'm extracting jobs related information from Lakeflow jobs table, and like with the previous queries, I am joining it to billing usage and list prices tables to get associated prices. Similarly, I have DLT query. One thing to notice here is that both workflow and the Delta Live table related data will come from the same Lakeflow jobs table. However, they will have different sub-columns on the usage metadata column. So to get jobs related data, I am using non-empty job ID filter here, as you can see. And if I switch to the DLT tab, I have very similar query, except here I'm using DLT pipeline ID not null query filter. And here is how my jobs and the Delta Live table related cost charts will look like. Okay, so to sum up, Databricks system tables contain lots of useful data. So they basically act as flight recorder in the plane, and by enabling these tables, you can create lots of very useful dashboards, either from cost analysis perspective, performance analysis perspective, or some other purposes. You can also create alerts based on this data so that you could react on certain data conditions. I encourage you to take a look at Databricks documentations I have shared here and play with the system tables and the dashboards, and I'm sure that you will like that. That's it for today. I hope you enjoyed. If you found this video useful, don't forget to hit the like button and subscribe to the channel. Thank you, and I'll see you in future videos.